In this video I'm going to explain how to answer multiple choice questions based on the topic of electricity. I'm going to do two questions and I've got one method for each question. When I show the question I'll pause for about 5 seconds so that you can pause the video and have a go at the question yourself, and I'll go through the method. So in this question what we're looking at resistance, we're looking at the dimensions of the resistors as well. So presumably we're going to be looking at this formula here to do with resistivity. It says the same material, so the resistivity will be the same for each on this one. We're given information about the diameter, but in the formula we've got area. So we need to know that cross-sectional area pi r squared is proportional to d squared. Now it's going to be comparing, it talks about R1 as being half the diameter, twice as long as that for R2. So what we're going to do is come up with an expression for R2, which is rho L over A. Now what we're going to do is have a look at R1 in terms of these. So we've got half the diameter, which means that we've got a quarter of the cross-sectional area. So I'm going to write down R1 as it's the same material, so the same resistivity, it's twice as long, and it's got a quarter of the cross-sectional area as R2. We're going to multiply out these numbers, so we've got 2 divided by a quarter gives us 8. So R1 is going to be 8 times rho L over A. But notice rho L over A is R2, so that gives us 8 times R2, which is answer A. Question 2. So we've got 800 megawatts of power being delivered at this voltage. We're going to be losing 1% as heat. Quick calculation there, 1% of 800 megawatts is 8 megawatts. So that's what we're going to be losing. So we're going to be delivering this power at this potential difference. So immediately you can work out the current that's going to be down the cables there. So we can work this one out, and this comes out as just over 6,000 amps. So what's the resistance of the transmission line? Well, we know that we've got 6,061 amps going down that transmission line, and we're losing 8 megawatts on the transmission line. So we need a formula that links resistance, power and current, which is this one. We can then rearrange this to get this in terms of R. So we've got R equals P over I squared, substitute in the numbers, and the answer we get is 0.22 ohms. So there you go, answer A.